Solving a system of equations using reduced row echelon form with matrices. So our goal is to have a matrix where we have ones on the diagonal. Your right-hand side will be the solution. So we take a system of equations and we write it into a matrix. And let's get started. So I want to get rid of the 2. So -2 of row 1 plus row 2 gives me a new row 2. So I'm using row 1. I will leave that the same. -2 plus 2 is 0. -2 plus -3 is -5. -2 plus 2 is 0. -12 plus 12 is 0. Now I want to get rid of the 4. So -4 times row 1 plus row 3 gives me a new row 3. So -4 plus 4 is 0. -4 plus 1 is -3. -4 plus -3 is -7. -24 plus 3 is -21. Now I want to make this -5 into a 1. So -1/5 row 2 gives me a new row 2. All right, I want to get rid of this -3. So I'll use row 2. 3 row 2 plus row 3 gives me a new row 3. Again, the row that you are using stays the same. So 0 plus 0 is 0. 3 and -3 make 0. 0 and -7 make -7. 0 and -21 make -21. And now I want to make this into a 1. So -1/7 row 3 gives me a new row 3. Next, I want to get rid of this 1. So I use -row 2 plus row 1 to give me a new row 1. So 0 and 1 makes 1. -1 and 1 makes 0. 0 and 1 is 1. 0 and 6 makes 6. Now I want to get rid of this 1, so I'll use row 3, negative row 3 plus row 1 gives me a new row 1. So 0 and 1 is 1, 0 and 0 is 0, negative 1 plus 1 is 0, negative 3 and 6 makes 3. And now we have reduced row echelon form. So our solution is x equals 3, y equals 0, z equals 3, or you can write it as an ordered triple. And you can check it by plugging it into your original equation.